Corporate Finance. Dear students, today is our sixth lecture of Corporate Finance. Today we will discuss the remaining part of time value of money. Dear students, if you remember in lecture 5, we started the topic of time value of money. I told you that time value of money topic is a lengthy topic. We cannot cover all the terminologies relating to time value of money, all the topics relating to time value of money be covered by us. So I told you that we will discuss some of topics in lecture 6. In lecture 5 we discussed the simple interest, the compound interest, the compounding concept as well as discounting concept. Also we discussed how to find out future value in simple interest, and also we discussed how to find future value in compounding interest. We also have discussed the present value, that how we compute, how we find out the present value on the base of simple interest. Also we discussed the present value on the base of compounding interest, on the base of discounting interest, on the base of compound interest. Dear students, in lecture 5 our all topics were in single deposition. The future value, the present value, the simple interest, the compound interest, all these terminologies were used on the base of single deposit. Single deposit means we paid or we received payment once at a time. Once a time means once we pay some amount to the bank and we were used to compound that original amount for some future time, for some future years. As well as we discussed present value on the base of single deposit, means that we wanted to find out, we wanted to know the amount which was given for the future time, and we were used to find out the present value of that amount, but for the single amount. But today we will discuss the present value and the future values on the base of multiple depositions. Multiple deposition means we find out the present value or the future value for the multiple depositions. Every year we pay some money to the bank, same amount to the bank, or we receive same amount from the bank, but in every year. So this is called multiple deposition. If you remember, we discussed the payment of once a year, once a time, but today we discuss payment of every year. So let me start with the very first topic of today's lecture, that is types of annuities. Annuities, the word annuities is derived from the word annual. Annual means every year. Annuity represent a series of equal payments. It's a series every year we pay some money to the bank, but this payment will be same, occurring over a specified number of equidistant periods. Equidistant periods means equal distant. Equal distant, every year is equal with another year. So this is equidistance. Equal distance means equal time. If you want to pay money to the bank every year, it means after 1 year, so it will be equal distant. If you want to pay to the bank after 6 months, so 6 months is equal to another 6 months. So these another 6 months are equal to another 6 months. So every 6 months you are going to pay to the bank. So again it is equidistant. There is equal distance between the payments. So today's lecture is about the annuities. Annuities means series of payments with equal payments with equidistant payments. Series of payments, equal payments and equidistant payments. Series of payment means every year you will pay. Equal payment means equal payments, same amount, and the equidistant means every specified time, every mentioned time. Annuity has two types. One is ordinary annuity and second is annuity due. Ordinary annuity means payment or receipt of any deposition occurs at the end of each period. It means ordinary annuity. It means that every 31st December we pay or receive money from the bank. Every 31st December. It is the end of the year. It is when investor pays money to the bank every 31st December. It means that the investor is paying money at the end of the year. So if this investor is paying at the end of year, it is called ordinary annuity. If the investor pays the money to the bank on the 1st January, it means it is start of the year. So this is called annuity due. Payments or receipts occurs at the beginning of each year. It means investor is paying money to the bank in every 1st January of the year. Means the 1st January is the start of the year. It's the beginning of the year. So this is called annuity due. Example of annuities: student loan payments. The concept of student loan is not in our country, but in abroad, in foreign countries, there is concept of student loans. Every bank provides student loans to the students. Students will not pay money from their savings. They pay their money to the colleges, to the universities by getting loans from the banks. This loan, which is used to study in university or in a college, this is called student loan. Car loan payments may be possible. Our country, there is a concept of car loans, but in foreign countries there is definitely the concept of car loans. Every person gets car from the bank by loan, and every year this person pays to the bank equal payment to the bank. Insurance premium, if you remember, insurance premium, this is also given to the insurance companies after 1 year in fixed amount, same amount. Mortgage payments means property payments, they are also paid to the bank or received by the bank same amount every year. And retirement savings are also fixed every year and they are paid to the retirement saving funds same amount. Why we use annuities? To find out the problems relating to the student loans, relating to the car loans, insurance premiums, mortgage payments, retirement savings. These are all the examples of annuities. Before I told you that types of annuity are types of annuity. In types of annuity, we discussed the ordinary annuity. In ordinary annuity, I told you that every person pays or receives money from the bank at the end of the year. So this is timeline from 0 to 3 years. So every 31st December, it means end of the year, the investor is going to pay or receive the money from the bank or to the bank. Again at the end of the year. So on this method, this method is called ordinary annuity. Today 0, but he is not going to pay any amount to the bank because the contract is ordinary annuity. The investor will pay $100 after 1 year. Again he will pay $100 after 1 year. Again he will pay $100 to the bank after 1 year. So if you see this timeline contains 3 years, and every year investor is paying $100 to the bank. Therefore it is called annuities. It is annuity. Therefore it is called multiple disposition. 1 deposition, 2 deposition, 3 depositions. It means there are 3 depositions, so it is called multiple deposition. If you remember in the previous lecture, in lecture 4, there was only 1 deposition, and another remaining years we were used to calculate the compounding interest on the base of one's payment. But now we will calculate compound the interest, calculate the interest on the base of every year payments. This is called multiple deposition. Clear? Next is the annuity due. Same like annuity, ordinary annuity, but only the minor difference, that is payment of the cash on the start of the year, on the beginning of the year. So you can see in timeline, the contract is made today, now, but in contract he paid $100 to the bank. Again on the 1st January he is going to pay $100. Again on the 1st January he will pay $100 to the bank. When use this method is called annuity due. Clear? You can see the amount is same, $100, $100, $100. The timeline shows that there is equal distance between every payment, from 0 to 1 year, from 1 to 2 1 year, from 2 to 3 1 year. So there is equal distance and equal payments. Clear? Next, overview of our ordinary annuity. If you remember in previous class, in lecture 4, we discussed only future value, but here is future value annuity. When A is added to the FV, it shows the annuity. If A is subtracted from the FV, it shows simple future value, not annuity. But here is A added with FV, so it shows future value annuity. From 0 to 1, from 1 to 2, from N till N. So these are periodic payments, periodic cash flows, inflow or outflow, doesn't matter, but there is periodic cash flow. Therefore it is called R. R means recurring, recurring, again recurring, again recurring. So what is the formula for the future value annuity? Future value annuity is equal to R, the cash flows, plus multiply by 1 plus I is interest rate, whole raised power by n minus 1 for first year, for second year n minus 2, for third year n minus 3, and so on, till we reach to the 0. So this is the formula for the future value annuity, ordinary annuity. This is the ordinary annuity, and in ordinary annuity we are going to pay the amount at the end of every year. At the end of every year Let me solve an example in this formula. Dear students, in lecture 4 in previous lecture, I also told you that if you are going to solve any example, first of all you should draw a timeline for that example. This is timeline for that example. You can see from 0 to 1, from 1 to 2, from 1 to 3, and from 3 to 4. If you see 1, 2, 3, 3 times the investor is paying money to the bank every 3 year for 3 years. Every year he pays to the bank for 3 years. So what is the interest rate? I is equal to 7%. Now how we calculate this problem? Future value annuity for 3 years is equal to, on the first we told you that we minus 1 from the first year, we minus 2 for the second year, and we minus 3 for the third year. So 1000 is payment, multiply by 1.07, 7% is interest rate, whole raised power by n minus 1. N minus 1 years are 3, you can see here 3 minus 1 remains 2. For the second year, 1000 multiplied by 1.07 whole raised power by n minus 2. N is equal to 3 minus 2 remains 1. For the third year, 1000 multiplied by 1.07 whole raised power by n minus 3. N is equal to 3 minus 3, which remains 0. How we can see? For 1000 multiplied by 1.07 whole raised power by 2 becomes 1145. 1000 multiplied by 1.07 whole raised power by 1 becomes 1070. And for third year, 1000 multiplied by 1.07 whole raised power by 0, it remains 1000, because everything which has power by 0, it becomes 1. So 1 multiplied by 1000, it becomes 1000, it remains 1000. So 1145 plus 1070 plus 1000, it becomes 3250. So the future value for the ordinary annuity for 3 years in the interest rate of 7% becomes 3250. You can see here, this is compounded for 2 years, this is compounded for 1 year, and this is compounded for 0 year, because we are finding this future value. So 1000 is not compounded because it is paid and back it is received without any interest. This is compounded for 1 year, and this is compounded for 2 years. Clear? Next, annuity due. In annuity due, I told you that every investor will pay periodic cash flows to the bank at the start or at the beginning of the year, the 1st January of the year. So one is paid in 0, second is paid in 1, third is paid in 2, fourth is paid in third year, so and so on. So formula for annuity due, FVADN, means future value annuity due for years n is equal to R multiplied by 1 plus I whole raised power by n, no minus. On the second year, minus 1. On the third year minus 2. On the fourth year, till it becomes future value n multiplied by 1 plus I. How? Let's solve example. If I is equal to 7%, the n is equal to 3 years. N is equal to 3 years. You can see here 0 to 1, 2 and 3. 3 years. N is equal to 3 years. So what will be the answer for this example? I told you before, first of all, to solve such examples, first of all you draw a timeline for that example. So from 0 to 3, you can see this 0 payment is compounded for 1, 2 and 3 years. The payment of 1 year is compounded for 2 years, 1 and 2, and the second year payment is compounded for 1 year. Clear? future value annuity due 3 years is equal to 1000 multiplied by 1.07 whole is power by 3. I told you before, for the first year there is no minus concept. For second year we minus 1, 3 minus 1 2. For third year 3 minus 2 remains 1. So let's solve. 1000 multiplied 1.07 whole is power by 3 becomes 1225. 1000 multiplied by 1.07 whole is power by 2 becomes 1145, and 1000 multiplied by 1.07 whole is power by 1 becomes 1070. It becomes 3440. Clear? Let's study the present value and ordinary annuity. How we use ordinary annuity and present value. Same concept, but it is divided, and always we multiply in future values, but in present values we divide. We are here, but we find out the present value in 0. How? In I percentage, in periodic cash flows with equal distance, but at the end of the year, not at the beginning of the year. End of the year, and end. What will be formula for that? Present value annuity, ordinary annuity for n years is equal to R divided by 1 plus I whole is power by 1. There we multiplied, here we will add. Difference in future value annuities we subtracted every year, and present value annuities we add. It's the against of the future value. There in future value we multiplied, in present value we divide. R divided by 1 plus I whole is power by 1 plus R divided by 1 plus I whole is power by 2. It is added. R divided 1 plus I whole is power by n, and so on. Clear? Let me solve with example. From 0 to 4, a timeline. Every end of the year $1000 are paid by 7% interest. You can see first year is discounted for 1 year, the second year is discounted for 2 years, the third year is discounted for 3 years. Clear? 1000 is discounted for 1 year in 7%. You can see 1000 divided by 1.07 whole is power by 1, it becomes 934.58. Second year is discounted for 2 years, so 1000 divided by 1.07 whole is power by 2, it becomes 873.44. Third year is discounted for 3 years, so it will become 1000 divided by 1.07 whole is power by 3, it becomes 816.30. You can add up all three and it will becomes 2624.32 present value ordinary annuity for 3 years. Clear? Next, annuity due. For annuity due we also pay on 0. In ordinary annuity we are not going to pay on 0 time, but in annuity due we pay on 0 time, or recurring amount, same amount on equidistance. So in I percentage, what will be formula? R divided by 1 plus I whole is power by 0 plus 1 plus 2 plus 3 and so on. Clear? The first 0 amount is not discounted because it is paid and received back without any discounting. So it is same amount 1000. Therefore it is powered by 0. Everything powered by 0 is equal to 1. 1000 divided by 1 is equal to 1000. First year is discounted by 1 year. 1 year discounting in 7%, it becomes 1000 divided by 1.07 whole is power 1. 2 is discounted for 2 years, so it is whole is power by 2. It becomes total becomes 2808.02. Next, steps to solve time value of money problems. How? First, read the problem thoroughly. Determine if it is present value or future value. Create a timeline. Before I told you You must draw a timeline, put cash flows and arrows on timeline. All cash flows must be put on the cash flow on the timeline. Determine if solution involves a single cash flow or annuity stream. It is a single deposition or multiple deposition or mixed flow. Solve the problem, then check the financial calculator, optional. Mixed cash flows. Dear students, in annuities we discussed the same amount. In this topic, in this terminology, we will discuss the mixed cash flows, not equal amounts. In timeline you can see in 10% of interest from 0 to 1 they paid $600, then $600 in second year, in third year $400, in fourth year also $400, but in 5 year they paid $100. There is equal distance but different amounts. So this is this different amount is called mixed cash flows or mixed flows example. How you can solve these problems? Piece at a time. By piece at a time, discounting each back to time 0. You can see the first year amount is discounted for 1 year, the second year amount is discounted for 2 years, the third year discount amount is discounted for 3 years, the fourth year amount is discounted for 4 years, and fifth year amount is discounted for 5 years. In 10%, this is a formula. Say 600 divided by 1 plus I whole is power by 1, then 2, then 3, then 4, then 5. So if we divide 600 divided by 1 plus I whole is power by 1, it becomes 45.45. If we divide $600 for 2 years on the power of 2, it becomes 495.87, and so on till the end. The total amount after 5 years in the present value becomes 1677.50 for the mixed cash flows. Clear? The process is same, only the amount is different. Frequency of compounding. Frequency of compounding means every time, every investment is not going to invest for 1 year. Most of the investors invest for the different time. For example, this example was the different cash flows. Frequency of compounding shows the different time. It means n number of years. It is formula for f future value n is equal to present value 0 multiplied by 1 plus I divided by m, or is power by m multiplied by n. N shows the number of years, m shows the compounding periods per year, I annual interest rate, and the future value at the end of year 1, and present value of the cash flows today. Clear? Now, how to solve the problems according to the frequency? Julie Miller has $1,000 to invest for 2 years at an annual interest rate of 12%. For annual is the same, no problem. 100 multiplied by 1 plus I whole 1 plus I divided by 1 whole is power by 1 multiplied by 2. It is 2 years. It becomes 12,1254.40. Semi-annual, it means every 6 years. The investor or Julie Miller want to get interest after every 6 months. So 1000 multiplied by 1 plus I divided by 2 whole is power by 2 multiplied by 2. So because he is getting interest twice in a year, so it becomes 1262.48. If you calculate quarterly, if the investor want to get interest after every 4 years, so divide I must be divided by 4, mean 12% divided by 4, and the power 2 multiplied by 4. It becomes 1266.77. If the investor want to get interest monthly base every month, it means it is I is divided by 12 and the n is multiplied by 12. It becomes 1269.73. If the investor want to get interest daily base every day, it means that I is divided by 365 days and 2 is multiplied by 365. It will become 1271.20. Clear? Next is the effective annual interest rate. Effective annual interest rate, the actual rate of interest earned or paid after adjusting the nominal rate for factors such as the number of compounding periods per year. The formula for effective annual interest 1 plus I divided by m whole raised power by m minus 1 whole minus 1, not the m minus 1, whole minus 1, whole formula minus 1. M is power for the bracket and minus 1 is for the whole formula. Clear? So, Basket Wanderers has a $1,000 CD at the bank. The interest rate is 6% compounded quarterly for 1 year. What is the effective annual interest rate? So, effective annual interest rate 1 is for the formula, 6% percentage interest rate. The 4 quarterly, he want to get quarterly, and the minus 1 is from formula. So, 1.0614 minus 1, it becomes 0.0614 or 6.14%. 6.14% is effective annual interest rate. Thank you so much. Thank you very much, dear students. I hope you will get the message from today's lecture. For now, have a good time, have a nice time. If you have any question, you can ask me through your WhatsApp group. Thank you so much.